Friends, will start the meeting now. And I just came to know that today morning Dr. D.P. Rao expired in Hyderabad. But I came to know only in the evening. Cremation will be done tomorrow morning. He, as you all know, he was former director of NRSA and also a Padma Shri holder and a thorough gentleman, a great geomorphologist. We miss him, and he is a member of our group very much. Our KMCT trust, he was a member very much. And then I think tomorrow I'm trying to go there and then offer condolences on our behalf personally and on my personal behalf also. It's a great loss to our trust as well as to the country. That's it.
Sound नहीं कर रहा.
Dr. Mike, you are muted, I believe.
Video.
Yeah.
Good evening, everybody. Good evening to Dr. Shenoi. Very happy to welcome Dr. Shenoi, who has been a very pioneer in the working in the oceanography, and he has a long experience in working in various aspects of ocean. Started his career in NIO, and I know him since he was working on sea surface temperature and the circulation and many other issues. And ultimately, he agreed to come to INCOIS at my request, where he worked for more than 11 years. And also for 3 years almost, he was the director of NIOT. And I think he's, apart from this, his contribution to the understanding of Indian Ocean and recently about Indian Ocean, second international Indian Ocean expedition is really noteworthy and praiseworthy. So I'm extremely grateful to him for agreeing and to speak on the deep sea technology and the science for the India's economy. I think he has tremendous experience both on the technology side and ocean science side, and how this can be leveraged for our work. So with this few words, I request him to deliver this talk, which is the 5th Krishnanunni Memorial Lecture. Over to you, Dr. Shenoi.
Thank you, sir. Thank you very much. At the outset, let me express my thanks and gratitude to the organizers of Dr. Krishnanunni Memorial Lecture Series, especially Dr. Shailesh Naik, President of this memorial, Dr. Parth Saradi, who was corresponding with me, and Dr. Rasik Ravindra, my earlier senior colleague, who also brought me to deliver this lecture. I am grateful to the organizers of this trust for giving me an opportunity to talk on a slightly different subject from geological aspects, because I know that most of the August gathering consists of geologists, but I am going to talk little differently, but of course it is directly related to geology as well. So with this introduction, let me go to my lecture. The topic I selected is importance of deep sea technology and ocean science for India's economy. As we know that the oceans are important because it contains 96% of living space on Earth and has 80% Earth's living organisms living in oceans, covers about 71% of Earth's surface area. Almost half of the oxygen we breathe is produced by ocean plants called phytoplanktons. And the fish from the ocean provides the much required animal protein for a large portion of the population. And 90% of the world trade is carried across the oceans through the ocean. And it holds an estimated 80% of Earth's mineral resources. So it is very resourceful. And
Dr. Shenoi, can you come to the slide mode, please?
It is not changing. This is second slide.
No, I think make it full screen.
I am seeing full screen here.
But no, it is not.
I also see full screen.
I am seeing full screen on my computer.
Okay, I am also seeing full screen, yeah.
Okay.
No, I am also seeing full screen. I think your connection may be slow. It will come.
It is full screen here.
Okay, fine then. Carry on.
Okay. As we know from time immemorial that the ocean contains the wealth. That is why whatever our Puranas or Itihas tells us that Devas and Asuras joined together to extract the wealth from the oceans. And the major goal was to get the nectar, but the bycatch also was precious because several bycatch, as we know that Kamadhenu, then Kalpavruksha, and so many other bycatch also came out, and they were also very precious. But I don't want to dwell much on Puranas or those stories. But this story gives us three lessons. One is that the selection of appropriate technology. We should select a appropriate technology to get the wealth out of the oceans. And collaboration is essential. That's why even though it was a warring group, the Devas and Asuras, they have decided to collaborate to get the wealth out of the ocean. And there is an environmental cost, sometimes very lethal. As the story says, the Kalakud poison came out. And that needs to be mitigated. Otherwise, it's very dangerous for the Earth as well. But today, we locate and associate living fisheries,
Request everybody other than speaker to mute, please.
And non-living resources like minerals, natural gas and oil, fresh water, or desalinate the fresh water, ocean water to extract the fresh water. And for transportation, safety and strategic importance, ecological sensitivity. And of course, we are challenged with the global warming and climate change. If you look at the maritime estate of India, India has a coastline of approximately 8,100 kilometers and an exclusive economic zone of about 2.37 million kilometers. That's about 64% of the total area of India itself. And waters around India are used for transportation, fishing, dumping of industrial waste, sewage, and extraction of oil and gas, etc. There are 12 major and 187 non-major ports located along the coastline, and they are vital hubs for import and export of goods. And also we have beautiful beaches, especially in Goa and some parts of Kerala, etc., and Andhra Pradesh, Odisha, and all. They are much used for recreation purposes. The mineral deposits in EEZ include oil, gas, ilmenite, tin, monazite, zircon, chromite, etc. And GSI has already, from the report, I understand that has completed seabed mapping of about 94% of EEZ, and focused mineral investigations has been done over 2.14 lakh square kilometers of selected area of EEZ. These reserves of, if you look at these reserves of ilmenite, rutile, granite, zircon, kyanite, and sillimanite, they are estimated to be about very good quantities, and approximate worth of these reserves of minerals are about 120 billion US dollars. So we have a lot of wealth within our EZ itself. And also we have this natural gas and oil deposits, especially D3 and D9 blocks in Kaveri Delta, which are expected to produce about 23.52 million metric tons of oil and 50.7 billion cubic meters of gas. So we have a lot of wealth lying around us. And in addition to that, the surveys show that we have these gas hydrates or the solidified methane deposits all along our continental margins. And one of the published papers says that the gas hydrates along the Indian margin is more than 1,500 times the country's current natural gas reserve. And only even if we produce 10% or extract 10% of these gas hydrates, we can meet our energy requirement for 100 years. That's what the estimates says. So within our EZ itself, we have mineral wealth, gas hydrates, and oil and natural gas deposits lying there. In addition to that, there are polymetallic nodules in the Central Indian Ocean Basin, and an area of about 0.75 million square kilometers is leased to India by International Seabed Authority of UN for exploration and demonstration of polymetallic nodules mining from Central Indian Ocean Basin. This lease area contains about 380 million tons of nodules containing 4.7 million tons of nickel, 4.29 million tons of copper, and 0.55 million tons of cobalt, and 92.59 million tons of manganese. So that now, as per the agreement with the Seabed Authority of India, we have to demonstrate how we will be able to mine, or we have to design that technology to do the mining. I will come to that little later. In addition to that, there are polymetallic sulfides. For example, the Seabed Authority has licensed to India about 10,000 square kilometers area on the Central Indian ridge and Eastern Southwest Indian ridge for the exploration of polymetallic sulfides, which contain copper, at least 3 commercially viable quantities of metals this polymetallic sulfide contains, and mainly they are copper, lead, zinc, iron, molybdenum, gold, and silver. Usually they occur in volcanic or magmatic hydrothermal environments. That's why they are occurring on those ridges where the seafloor is keep on moving apart. These hydrothermal vents they look something like this, producing those polysulfide deposits, and normally they are produced from these kind of chimneys where that magma tries to come out from the Earth's interior, and when it comes in contact with the seawater, it forms as sulfides and gets deposited around those chimneys. Now we have to use a host of geophysical, oceanographic, and geological tools for the identification of massive sulfides on the seabed, because we are licensed to explore those areas about 10,000 square kilometers, and India has taken initiatives in doing that survey. And the first step of a reconnaissance survey or regional surveys using multi-beam bathymetry, hydrographic surveys, water sampling, shipboard sediment or rock sampling, magnetic surveys, etc. have been completed in that area. And now we have to do this survey with even the focus survey around these live chimneys using AUV bathymetry, side scan sonar mapping, bottom profiling, vertical cable seismic surveys, electrical and electromagnetic surveys, and use a ROV to collect the sediment and rock from the right spots. And after that, the video imagery has to be created using ROV and do focused sampling of these sulfides as a contract between Seabed Authority of India and Government of India. NCPUR, where earlier Dr. Rasik was director there, that institute is leading these surveys and mapping of this sulfide areas. And to demonstrate that, we will be able to mine the polymetallic nodules, which are laying at around 6,000 meters deep water in the central Indian Ocean. We have started developing integrated mining system. It consists of a mining machine which should move on the bottom and pick those nodules, which we can call a collector or a crawler or whatever it is. And then those nodules has to be crushed and pumped to the mothership using a high pressure pump, and a riser will then take it to the mothership. So this much technology has to be developed to demonstrate that we will be able to mine those manganese nodules laying at a depth of about 6,000 meters in the central Indian Ocean. So the first, as a first step, we have already developed the National Institute of Ocean Technology has developed a mining a deep sea mining machine and named it as Varaha 1, and it has already been tested at 5,270 meter on the seabed in the central Indian Ocean. And this mining machine can crawl on the seabed and pick those nodules and crush them on board, and then supply to the flexible riser using a S-transfer tube pump. So that part has been well tested, and we have that technology to pick those nodules from the central Indian Ocean from a water depth of about 6,000 meters. Then before we lower such a heavy machinery which weighs about 5 tons, 5 to 6 tons, we had to test the soil, whether that soil when we lower such machinery, it will get stuck in the loose mud on the ocean bottom, or it can withstand. So for that, a in situ soil tester has been developed, and that also is well tested in that mining area of a depth of about 5,462 meters. So these two technologies are already developed, because these are very challenging technologies which no other country will share with another. So the this technology has to be developed by us indigenously itself. So that has been developed, and Also, a deep sea autonomous coring system also has been developed, which can do the coring of about 100 meter below the seabed at a water depth of about 3,000 meters. This has been developed for those kind of depths because mainly this has to be used for the validation of those gas hydrates or the solidified methane gas hydrates, and the depths for which that machine is required is about less than 3,000 meters only. So the technology is developed to do this coring up to 100 meter below the seabed at depths of about 3,000 meters. This technology also has been developed and tested well now, and it is available with us now. Along with that, two ROVs or remotely operated vehicles have been developed. One has a capability of going down up to 6,000 meters, and this has been used for search and rescue of several times, including that naval aircraft which was lost in the Bay of Bengal about 2-3 years ago. And this ROV was used to search for that at depths of about 3,000 meters. And another ROV called shallow ROV or ROV 500 also has been developed and now in use for mapping coral reefs and other shallow water phenomena in the Indian EEZ. Now NIOT is on a mammoth task of developing the manned submersible called Matsya 6000 or a Samudrayan, which can carry 3 people, 1 pilot and 2 scientific crew, and dive down to about 6,000 meters, stay there for about 12 hours, and then can be retrieved back by the mothership. So this is being developed now. Already some of these components have been developed and being tested. And the target is that by 2024, we should be able to send 3 people in our own submersible, which is called Matsya 6000, to map the ocean floor. Once this is developed, this can be used to examine those chimneys of sulfide emitting regions of the western Indian Ocean, and also they can do the sampling of the sulfides as well as other living organisms which are present there. So this is very crucial for the success of several of these kind of projects, and that is being developed now. And this is one of the important component of the large project which has been launched by Government of India an year ago called Deep Ocean Mission. This is one of the important project under that mission. Then other resource, what we can get from the ocean is energy and fresh water. There are 4 types of energies which we can extract from the ocean. One is the wave energy, tidal energy, then ocean thermal energy, and offshore wind energy. And the estimated potential for wave energy around India is about 90 gigawatts, and the levelized cost of electricity for the wave energy is about US dollars 350 to 670 per megawatt. So that kind of a investment is required to set up these wave energy plants, and before that we have to develop those technologies. A pilot plant was developed in 1991 and was installed at Vizhinjam in Thiruvananthapuram, Kerala, which was which was designed to produce about 150 kilowatt of energy using that huge plant which was installed there. But it could not be sustained because the technology was not very appropriate, or because of the harsh sea conditions and corrosion effects, it could not be sustained. And now alternate technologies has been being experimented and tried out. One of the technology which has been successfully demonstrated recently is a backward bend ducted buoy, which is working at Ennur Harbour and is able to produce 1 kilowatt energy from the waves. And this need to be scaled up and industrialized to sustain for larger plants. This also has been developed by NIOT in the recent days. Other energy which we can extract is the tidal energy, and country has a tidal energy potential of 8,500 megawatts. About 7,000 megawatt is available from Gulf of Kambat, because the tidal ranges in the Gulf of Kambat are quite large, about 4 to 5 meters tidal range you can get there, and 1200 in the Gulf of Kutch, and 100 megawatt potential is there in the Sundarbans region of West Bengal. And for that also the estimated or levelized cost of electricity for the tidal energy is about 333 to 625 US dollars per megawatt. In fact, two projects have been initiated, but some or other reason, one project for 3.75 megawatt of electricity and 50 megawatt of installed capacity were initiated in 2007 and 2011 in West Bengal and Gujarat respectively. But both projects were dropped because of the exorbitant costs, or there was no funds for capital investment, and these projects were shelved in fact. But there is a potential, and we can develop the appropriate technologies to bring down the cost and extract the energy from the tides, at least from those regions. This maps shows the offshore wind energy availability on a monthly basis as well as annual basis. In fact, it shows the climatology of wind power density. And the National Wind Energy Mission has set a target to realize 204 gigawatt of wind power generation capacity by 2047. And if we have to achieve that target which has been set, we have to look for the offshore wind energy, because offshore the advantages are the winds are stronger than what we experience on the land, and also the winds are more consistent because no much obstacles and friction experienced by these offshore winds. And of course, when land is a premium on the land for the installation of such huge turbines, offshore areas are more attractive, though the initial capital cost is slightly more than what is required for the installations on the land. And the two areas, especially the southern coast of Tamil Nadu and the coast of Gujarat and Maharashtra, have higher potential for wind energy, and they are commercially viable. That's what it says. In fact, NIOT Chennai has studied the commercial viability of the wind turbines in potential sites and estimated that unit price will be about rupees 8 to 10, and the capital cost is expected to be about 20 crores per megawatt. Of course, further research might improve the technology and might be able to reduce these costs of energy as well as the capital costs. And coming to the freshwater generation, one of the method which normally or many are following is the reverse osmosis. But reverse osmosis has its own environmental effects because it throws out the brine or high saline water in back, damaging that environment around that region. And another technology which has been developed by NIOT is low temperature thermal desalination technology, which makes use of the temperature gradient in the ocean because the surface waters are more warmer. So you pump that water into a flash chamber which is at a very low pressure, and that low pressure flash chamber allows the evaporation that warm water within that. And, hello. Somebody's microphone is on, I think. Some noise is coming.
Yeah.
And the cooler waters, for example, if you go down about 1,000 meters, you can get water around 8 to 9 degrees temperature. So use that water to condense that water vapor. So this is the technology, or this is the principle based on which this low temperature thermal desalination works. And already a plant of 100,000 liters or 1 lakh liters per day is working in Kavaratti since 2005. Even today also it is producing the water and supplying for the island inhabitants in Kavaratti. So, and in 2011, similar plants were installed at Minikoi and Agati also. As you know that there is no other source of water for these Lakshadweep islands, which are just a narrow strip of coral islands or very small islands. They cannot even store the water. There is no space for storage also in those areas. And this is the only technology which can sustain there. And it has almost zero maintenance or very little maintenance. And the local youth who have little training, they are able to maintain these plants and produce this water on a daily basis. And now seeing the advantage of these plants, Ministry of Drinking Water and Sanitation of Government of India has asked NIOT to install another 6 plants at 6 islands, Chetlat, Kiltan, Kalpeni, Kadamat, Amini and Androth. Already the work has been started. Kalpeni plant has already been commissioned in 2020 itself, and due to this pandemic, things got delayed, and it is expected that the Kadamat and Amini also will be, and Chetlat, these 3 plants will be commissioned by end of this year itself, sometime in October, November. That's what I learned from NIOT. And Kiltan and Androth plant, that those 2 plants also will be commissioned in sometime in next year. So that's the acute problem which is faced by the Lakshadweep population for fresh water will be completely solved after the commissioning of these plants. So these technologies are very indigenous technologies and has been done indigenously by the MOES institution, National Institute of Ocean Technology in Chennai, and they are working fine. Now, the other major resource which we can get from the seas or ocean is the fisheries. So let us have a look at the Indian marine fisheries scenario. We have a long coastline of about 8,000 kilometers and exclusive economic zone of 2.37 million square kilometers, of which about 0.5 million square kilometer is territorial waters. That means the waters within 12 nautical miles from the coast is called territorial waters, and inshore area of about 0.18 million square kilometers. These two areas, territorial waters and inshore areas, the fishing is controlled by the state governments, and the waters outside the territorial waters and within exclusive economic zone are controlled by the union government or central government. And we have about 3,477 fishing vessels, and we have a huge number of vessels operating in these waters, mechanized vessels about 72,000, motorized vessels 71,000, and non-motorized canoes and country boats like vessels 50,000. So nearly 2 lakh fishing vessels, which according to one of the survey and studies, it is too much. We should not have that many plying there. But the story is that in spite of all that, we are producing about maximum we produced so far in 2012 was 3.94 million tons, and much less during several other years, in spite of all these people and the boats which are used. If you look at the fishers population, it is about 3.7 million or nearly 40 lakhs. And the active fisher population means those who are going out at sea for fishing, go in this one of these motorized or non-motorized boats for fishing. That is about 0.9 million or 9 lakh fishermen go out at sea for fishing. But so far we produce less than 4 million tons, and the estimated harvest is about 5.31 million metric tons. That means nearly 1.5 million metric tons of fish which is available there, but we are unable to catch that. So harvestable yield of non-conventional deep sea like mytophids, oceanic squids, jellyfish, etc. That also is there another 1.85 million metric tons, which that also we are not taking advantage and harvesting that. So if you look at the Indian fisheries and elsewhere at a quick glance, our fisheries have species richness. It says that we have more than 1,200 species in Indian seas, compared to 20 species in temperate waters. They don't have much variety there, but we have many more than the 1,200 species in our waters. And considering that we have 8,000 kilometers and 3,700 and odd fishing villages, that means we have one village every 2 or 2.5 kilometer of coastline. And active fisher population in India is 0.9 million, and we produce on an average 3.77 million metric tons of fish per year. If you look at the active fisher population in Iceland and New Zealand together, it is not more than 12,000. And these two countries together produce 2.6 million tons annually. That means they are producing 216 tons per fisherman is producing 216 tons fish annually, And Norway also has 12,000 active fishermen, and they produce 3 million tons annually. And they have 6,000 fishing vessels and 2.1 million square kilometer of EEZ. And if you look at that with 0.9 million fishermen, what we produce is about 2.4 ton per fisherman. That means we are very ineffective in producing the fish. We are more people, but we produce per head itself a very little fish, not even 1/10 of what Norwegian or New Zealand or Iceland fishermen produce. So of the 2.37 million square kilometer area, 8% is administered by state governments and 92% is by central government. And if you look at the our fishery requirement, by the time this estimate is for 2050, we will have about 70% of our population will be eating fish, and per capita fish consumption, considering 17 kilogram per annum, we will require about 20.20 or 20 million metric tons of fish. And expected marine demand is 50% of this. That means from marine, at least 10.1 million metric ton of fish should come from marine environment, and other 10 is expected from the inland fisheries and other sources. So, but right now we are producing only not even half of this 10.1 million metric ton. So there is limited scope for increase in production from present grounds. Even if we produce harvest that harvestable 5.31 million metric tons, we will not be able to reach 10.1 million metric tons, which is expected to support our population in 2050. So the balanced demand supply gap of about 50% should come from sustainable technological interventions like focused fishing, mariculture technology, and better managed fishing. Unless we adopt that and move towards that kind of a fishery management, we will have severe problems with the fish availability for our population. So the focused fishing, one of the technique which has been used right now, which may have to be scaled up and popularized further, is the potential fishing zone advisories, which are being provided by INCOIS, International Center for Ocean Information Services in Hyderabad. And along with that tells the fishermen where the probable fish catch could be better, and those areas it demarcates using the satellite data, and this information is passed on to the fishermen on a daily basis, so that fishermen are able to go there and conduct the fishing. Along with that, for their safety and for confidence, the ocean state forecasts are also issued on a daily basis about the winds, waves, temperature, salinity, mixed layer depth, thermocline depth, and the ocean currents, how that will be at that location and en route to that location. That kind of information also is provided to these fishermen, and they make use of that and conduct the fishing. And some of these independent studies conducted by a national survey conducted by National Council of Applied Economic Research in 2010 as well as 2015, it says that identification of PFZ or potential fishing zones as well as ocean state forecasts by INCOIS are found to be both timely, accurate, and significant value to the fishing community. And the benefits they estimated is about 34 to 50,000 crore can come just by adopting or using these advisories for fishing. And another advantage of using these advisories is that the fishermen can go to those targeted areas and conduct fishing and avoid wastage of fuel. Otherwise, they have to burn in search of the fishing ground to conduct the fishing. So that study also has been done by National Agricultural Innovation Project for a village in Raigad in Maharashtra, and they find that this helps in saving the diesel, and hence the emission, it cuts down on the carbon dioxide emissions also from these boats by using these kind of advisory. So that is one of the technique which need to be adopted by every fisherman, so that their diesel cost can be brought down, time in fishing and search for fishing can be avoided, or that can be minimized, and they can get better returns during the fishing operations. Now, because the territorial waters fishery is a state subject, what is happening in our country is that each state has its own rules, and they declare the fish ban period, because during the monsoon, the spawning season, no one is expected to go out and catch the fish, because then you will destroy the fish eggs and juveniles, and the next season you will not have any catch left out there. So each state has their own decisions on when this fishing ban has to be done. But neither the fish or the fisherman who goes out at the sea knows these boundaries. They don't go by Kerala government's dates or Karnataka government dates. So they may go and fish in the Karnataka waters, or Karnataka fishermen may come and fish in Maharashtra waters or Kerala waters. So all this is happening, and it is complicating the picture. So that management strategy has to be unified, and also the specifications on what should be the minimum length of fishing, so that the juveniles will not be destroyed. All that has to be standardized and put out uniformly in the country. So to overcome that, it is suggested that the fishery area, instead of state-wise, it should be categorized, or at least the EEZ part should be categorized in only 6 regional zones. This is depending on the fishery habitat and its ecosystem. The CMFR, the Central Marine Fishery Research Institute, advises that it should not be state-wise, it should be common 6 zones considering the fishery in each of those regions, which will consist of 4 at the mainland and 2 for the island regions, Lakshadweep group of islands and Andaman Nicobar group of islands. And FAO's code of conduct for responsible fisheries should be implemented. Otherwise, we will not be able to sustain the fisheries, because people go and catch everything and destroy that. That should not happen. Implementation of minimum legal size across all states, it should be uniform, and standardization of fishing gear and craft across all states. No one should be using the fine mesh nets so that they can catch more fish, but it will destroy most of the juveniles and not fully grown fish. So that should not happen. And awareness campaigns among fishers and the multi-stakeholders is necessary to educate them that if they catch now the young ones or the not the adults, then in the long run it will destroy the fishery, and they will not be able to catch any fish later. Similarly, we had to develop the strategies fish in the deep sea fisheries like oceanic squid, oceanic tuna like other fishes, and mesopelagic fishes. They are also available about 1.8 million metric tons. So that also can be encouraged, and policies has to be made for these deep sea fisheries. And the promotion of sea farming is necessary, otherwise we will not be able to produce that required 10 million metric tons from the marine environment. Already NIOT as well as CMFRI has developed cages. CMFRI has installed more than 2,669 cages in the fishing villages, forming these self-help groups, and they are able to harvest fish from those cages. But the issue is that we should be able to scale up those number of cages. The estimate is that we have a potential of 82 kilometer square, because we have 8,000 kilometer coastline, and even if we use 1% of that area, about that will work out to be about 82 kilometers and 82 square kilometers, and each cage might require about 100 square meter area. So we can install 0.82 million cages, and those cages, even if they produce 5 tons per cage per crop, we will be able to produce at least many of the varieties which has been developed by CMFRI and NIOT. They can produce 2 crops. Even if we take 1 crop, they can produce 4.1 million metric tons. So if we promote this cage culture and deep sea fishing, and also increase our efforts to harvest what is harvestable right now, that is 5.21 million metric tons. Added all together, we will be able to reach that figure of 10.1 million metric tons, which are required to feed our population by 2050. Another importance of ocean is that ocean is closely linked or controls our weather and climate system. As we have learned from our high school itself, that the monsoon is a oceanic phenomena. When the Indian Ocean gets warmed up during the summer, and the low pressure system develops over the land, because land gets warmer faster than the ocean, and those monsoonal winds set up and bring the moisture from the ocean, and we get the monsoon, what we are experiencing now. And 2 oceanic modes, one is called El Niño, La Niña, which is mainly happening in the Pacific, but it has repercussions on the entire world, especially on our monsoons. They are very much controlled by El Niño, La Niña conditions, and also the Indian Ocean dipole. In normal conditions, usually the eastern side of the Indian Ocean is slightly warmer than the western side, and that is favorable for our northeast monsoon, etc. And during certain years, the eastern Indian Ocean, central eastern Indian Ocean becomes cooler, and the western becomes warmer, so it is reversing. So this is called Indian Ocean dipole. If you remember in 90s, when Vajpayee government was facing that onion crisis because of the unseasonal rains in in November, December months. That was because there was a strong IOD developed during that period, and it gave a lot of rains, over unseasonal rains over India, spoiling all onion crops, and the onion prices shot up. and in the next election, government lost its majority just because of this IOD phenomenon of that year. Added to that, we are facing the global warming or climate change. If you look at where this excess heat which is going on in the Earth system is going, the estimate says that 93% of the extra heat which has been gone into the Earth system since 1971 has gone into the oceans. So our oceans are taking maximum amount of heat which we are putting out into the Earth system, and 3% is going in warming the land, and 3% in melting of ice and glaciers and ice sheets, and 1% is warming the atmosphere. And if you look at the Indian Ocean, you can see these bottom two panels. During 1993-2002, Pacific was more warmer, and comparatively the Indian Ocean was slightly cooler comparatively. But since 2003-2012 data shows that the Indian Ocean is warming much faster than the other oceans. So you can see that those blue colors have gone, and yellowish and red color is started appearing in the Indian Ocean, and Indian Ocean is continued to be warming due to this climate change what is going on now. One of the effect of climate change is, or the immediate effect is that the sea level will increase because of the two reasons. One is because the warmer waters, the water will expand, the thermal expansion of the water expands and occupies more area, so the sea level will rise. And another reason is the glaciers in the mountains like Himalayas or Greenland ice sheets and Antarctic ice sheets. They will melt. That will add more water into the ocean, and the sea level is increasing all over the global ocean. And along the Indian coast also, on an average during 2000s, the sea level has increased by about 1.7 millimeter per year. But the recent study using the satellite data or the altimeter data, which shows that the that increase has doubled from 1.7 millimeter per year. Right now, the altimeter data shows that it has doubled to 3.2 millimeter per year. That is, in the recent years, the sea level is increasing at a much faster rate. Of course, we had to confirm that using the analysis of sea level gauges, which are more accurate than the altimeter estimates. But the global averages also are showing that globally the sea level is increasing at a rate of about 3.2 millimeter per year. So this rate also could be more or less correct only. So that will cause problems for the coastal regions. We will not only we will lose the land area, we will also lose the habitats there, the ecology of that region, biodiversity, and also the installations which are right on the coast, they will all get affected. And due to the impact of climate change, we are getting more warmer days and warmer nights, and the projections are that this is going to increase if the under these different scenarios. So whether it is a 2.6 RCP, 2.6 or 4.5 or 8.5, the warmer days are number of warmer days are going to increase only, and we are somewhere much above RCP 4.5 right now. So we have to worry more about the more warmer days and warmer nights. And due to this climate change, the heat waves over India are keep on increasing. The data during 1960 60s to 2015 shows that it is keep on increasing the number of days, and it has a close connection with the sea surface temperature in the eastern equatorial in the equatorial Indian Ocean. It is closely related with how the equatorial Indian Ocean gets warmer, and our heat waves over India have a very close relationship. That's what it shows. So we have to watch the ocean to make a better prediction of heat waves over India. Similarly, the extreme rainfall events, these days we get either torrential rains or no rains. So these are called extreme rainfall events. And since 1950 data onwards, it shows that the extreme rainfall events have increased threefold over India during 1950 to 25. And this also has close relation with that is happening because of the low level monsoon westerlies over Arabian Sea due to warming SST driving surges of moisture supply. So as the Arabian Sea sea surface temperature gets warmer, it drives a lot of moisture onto the land, and we are getting this kind of torrential rains. In short gaps, we get huge quantities of water, which will lead to flooding, etc. And the cyclonic storms, though the total number of cyclonic storms shows a decreasing trend, but the extreme severe cyclonic storms are showing an increasing increase, or the number of cyclones are fewer, but whatever cyclone forms, they are very furious and very destructive, and the model simulations predict that this intensity is their intensity is going to keep on increasing, and we will have more and more severe cyclonic storms over India in the coming years. And the flood events, we can see that if you open your newspaper any day during this monsoon season, you can see the flooding in most of the areas of India here and there, and which is causing severe losses like 3 billion US dollars per year, which is 10% of global economic loss. That much loss we are facing because of the flooding areas. And climate model projections indicate increase in frequency, spatial extent, and severity of droughts and floods over India during the 21st century. To make these predictions and keep watching them, we have to make good observations of the ocean, because all these events are directly related to what is happening in the oceans around us. We need to have this kind of observing systems. That this right side map shows that the kind of observing systems right now we have in the Indian Ocean, contributed by us, as well as some of the other countries like US and US, France, and Japan also has some observing systems deployed in this area. But India is contributing nearly 80% of these observing systems in the Indian Ocean, which consists of autonomous profiling floats like Argo floats, which dives down to 2000 meters and then comes up every 10 days or as programmed even on a daily basis, and reports temperature salinity profile via a satellite. Along with that, other parameters like oxygen or chlorophyll also can be reported by those kind of floats. Then we have this moored buoys, or the buoys which are anchored on the seabed, which are managed by National Institute of Ocean Technology. We have about 14 of them in Bay of Bengal and the Arabian Sea, and freely floating satellite tracked drifters to measure the sea surface temperature and the atmospheric pressure. Then the sea level gauges, then current meter mooring arrays, acoustic Doppler current profilers, and the robotics like gliders, which are being deployed from research ships. They are also operating in the Indian Ocean. So on the whole, we have much more data coming in compared to, plus the data from the satellites, Indian satellites, as well as the NOAA or NASA satellites and other country satellites. That also is providing several data sets. So compared to the situation what we had about 2 decades ago, especially the last decade or last 10 years, we made tremendous progress in observing the Indian Ocean, though still we have to increase the number of observing units in the Indian Ocean. But we have we have come long way in observing the Indian Ocean and deriving that data. In addition to the climatic impacts of the ocean, we also have the hazards, ocean genic hazards like tsunamis, storm surges, sea level rise, water quality, etc. You remember that in 2004 we had one of the worst earthquake, 9.1 magnitude earthquake, and a worst tsunami, which took a toll of about 2.38 lakh people from Indian Ocean countries. India also lost nearly 17,000 people, and more than 5,000 are missing or unaccounted in India itself. So huge loss of lives, and India itself lost about $7 billion damages due to that tsunami. And another hazard is the storm surges. In 1990, that super cyclone in Odisha killed about 10,000 people, and a lot of loss and damage due to that. A tropical cyclone Amphan that occurred in May 2020 affected India, Bangladesh, Bhutan, Myanmar, caused the loss of about $13.7 billion and 128 people lost their life. So compared to that 10,000 or lakhs of people in Bangladesh died because of the cyclones in 1990s. Now the figures have improved much, and we should be able to control even those numbers using appropriate technologies. In case of a tsunami, we have set up a tsunami early warning system which is fully functional at INCOIS. Dr. Naik was instrumental. He was the director of INCOIS at that time. This tsunami early warning system was set up, and not only we have set up the tsunami early warning center, which consists of the seismic network. In addition to our own seismometers in India, we also have networked the seismometers all over the world. Nearly 400 plus seismometers are networked, and we are receiving the data in real time. Within a few seconds itself, we are receiving the data whenever there is a earthquake occurs anywhere in the world. And we also have networked with the sea level gauges, tide gauges along the coast. Not only our Indian tide gauges, we have 36 tide gauges along the Indian coast. Not only those, but also the tide gauges in other countries like Indonesia, Australia, in Africa, in islands, etc., and also in other oceans. And the bottom pressure recorders or the tsunami buoys, which India also maintains, as well as other countries, especially US and Japan, those buoys are also networked. So we receive the data instantly at inquires, and we make use of that data as well as the modeling techniques to provide tsunami early warnings, not just the ocean basin wide. We are able to provide location specific, that is every 50 kilometer of the coastline we are able to tell whether tsunami warning is required, or tsunami watch, or tsunami threat is existing for that portion of the coastline, so that the disaster management agencies can concentrate only on those areas in evacuating the people, or providing the necessary help, and ignore other areas, and that reduces economically the unnecessary expenditure, and more importantly the tension and the chaos in evacuating the entire population along all the coastlines. And now this technology is being adopted by other tsunami early warning centers also, and International Oceanographic Commission of UN has accepted this as one of the technology which should be the standard for every tsunami early warning center. And IOC of UNESCO has designated our tsunami early warning center as the responsible tsunami warning center for providing tsunami warnings for the entire Indian Ocean. So we are not only providing tsunami early warnings only for India, we are also providing for other 23 countries on the Indian Ocean rim since 2012 onwards. Similarly, the storm surge warning also, we have made very good progress using the mathematical model and GIS tools. So now we are able to provide this storm surge forecast up to the village level, which are the villages which will get affected, and to what extent the flooding will occur in those regions. And those forecasts are provided by inquiries through India Meteorological Department, because that storm surge warning goes along with the cyclone warnings of India Meteorological Department. And the recent all cyclones, Tukte, Yas, Gulab, Shaheen, Jawad, all these inquiries has provided those storm surge warnings. In addition to that, the pH of oceans are keep on changing. In fact, we don't have a large amount of data on pH of the oceans or ocean acidification, because the pH change, the ocean water is becoming more and more acidic, which is not a very good thing to happen, because that will affect the life in the ocean, the fisheries, the flora and fauna of the ocean, coral reefs, all calcareous shell organisms, everything will get affected. And along with that, the oxygen content in the ocean waters are also decreasing, especially in our waters. It is alarmingly low in the Arabian Sea as well as Bay of Bengal, which is called low oxygen levels, or oxygen minimum zones in the North Indian Ocean. So this is also is a big challenge for us, and the models, the IPCC models consistently show that the oxygen deoxygenation will continue during the 21st century because of this global warming and climate change, and that's an alarming state. So the oceans, once thought to be a vast and indefinitely resilient able to absorb all pressures of human population from resource exploitation to fisheries and minerals, is going under severe stress now. And according to the first World Ocean Assessment, our civilization is running out of time to avoid the detrimental cycle of decline in ocean health that will have dramatic repercussions on the ability of ocean to keep providing the support we need. So considering this alarming situation, now the UN has declared the decade 2021 to 2030 as a UN Decade of Ocean Science for Sustainable Development. And the vision of the decade is that develop scientific knowledge, build infrastructure, and foster partnerships for sustainable and healthy ocean, so that we will have the ocean we need for the future we want. And for that, the science we have to develop for the ocean we need for the ocean we want. So these decade activities are going on in the Indian Ocean. We have already launched the International Indian Ocean Expedition 2 in 2020 itself. It completed the first 5-year segment in 2015, and now that has been extended for another 5 years, in which more than 30 countries are participating and concentrating on the Indian Ocean on various aspects. And that expedition is going on very well, which is coordinated by Intergovernmental Oceanographic Commission of UNESCO and the SCORE Scientific Committee on Ocean Research. These two organizations are and IOGOS, Indian Ocean Global Observing System. So these three organizations are promoting that collaborative project, which is concentrating on the Indian Ocean to understand the ocean dynamics, ocean fisheries, ocean this deoxygenation, as well as ocean acidification, and the links of better understand how the ocean is influencing our monsoon and other weather phenomena, including the extreme rainfall events, droughts, etc. So at the end of the decade, it is expected that we will have a clean ocean, a healthy, resilient ocean, a predicted ocean, because we have to develop better and better models to predict the ocean, and a safe ocean, sustainable and productive ocean, a transparent and accessible ocean. That is what we are aiming for at the end of 2030. And to sum up, the evidence is very clear. The time for action is now. With this slide, let me conclude, and thanks to all of you.
Thank you very much, Dr. Shenoi, for your exhaustive talk on marine sciences asset. I think we can take 1 or 2 questions if they're ready. Those who want to raise questions may unmute and then ask questions.
I am Balakrishnan.
Please unmute and ask.
Yeah. Can you hear?
Yeah, I can hear.
Yes, Balakrishnan, tell me.
Dr. Shenoi deserves our congratulations for dealing with such a vast subject and giving us so much information about the ocean. I just have one small question. Earlier, we had thought of a project called OTEC, Ocean Thermal Energy Conversion, and some work was done on that by NIOT or Madras Institution and all. Whether the one which you are now referring to as LTTD or whether it is a new avatar of OTEC, and if so, what is the difference?
Yeah, uh, that low temperature desalination, which I spoke about, that was sort of a spin-off from the earlier OTEC, though OTEC didn't succeed earlier.
Yeah, that's good.
This spin-off came and that was used for the desalination purposes. But right now, energy, constructing a plant using the water to generate the electricity for the desalination. So now they have come up with better technology which will be able to sustain and produce electricity required for desalination. So that is going on in Turkey, because it is not at it's not yet reached the commissioning stage, so that's why I didn't mention about it. So given up on OTEC experimentation and implementation is being tried now. So we have learned a lot from the earlier failures, and the technology is being improved. They are trying to commission a OTEC plant, OTEC-based desalination plant in Savar going.
OTEC failed probably because it was very expensive.
Yeah, it
The
is expensive
power
and
generation.
the kind of technology and our industries in this was done in early 2000. Our industries are not coped up to make those kind of machinery gadgets which are required. So that was also another reason failure to plant those things. Industries are better equipped and they will be able to provide such machinery as per the designs which are being given to them.
Hello. May I put a question? Hello.
Yeah, I can hear you. Dr. I can hear you.
Any other questions, please?
Noise coming on. So if those who are not asking, mute the mic. Yeah, Dr. I can hear you. Please go.
We are not able to hear anything.
Somebody's mic should be muted.
Kindly unmute the mic.
They have put on the TV, I think.
Looks like that.
Sounds are coming in.
What's happening? Subhasati
Yeah.
singing.
Patsar sir,
Please.
not only that, they have put the mic on and speaker off. So whatever we say, they will not hear.
I think Dr.
Please,
Speaker off.
please
Yeah.
mute your microphone, please. Hello. Hello. Please mute your microphone, please.
I think it is coming from the bottom of the ocean.
Please put on the mic.
Someone called Ramani Raja Venkat, that microphone is on, and somebody called Srinivas Rao, that also the microphone is on.
Yeah, but I'm sitting in my room alone and there is nobody.
No, I'm just seeing from the list here.
Yeah. I just want to thank Dr.
Shenoi for an excellent presentation on a very comprehensive presentation on a very vast subject. It's a wonderful subject actually, and as a mining engineer, I think of minerals. Of course, energy is another aspect. Fresh water is another aspect. Food was one of the things that was discussed. And then, of course, all these other what we call as climate changes. The monsoons, the hazards, the tsunamis, and the ocean pH and all these things. But whatever we are going to do with regard to minerals, energy, fresh water, and food, it's going to affect all these other things. What we don't know, we probably don't know what the effects are going to be. So I had a question for Mr. Shenoi. What are we trying to do? Increase energy production from oceans, increase food production from oceans, increase extraction of minerals from oceans. What are we trying to do to the oceans?
Yeah, let me take one by one. Thank you very much for a wonderful question. See, if you look at the energy from the ocean, there are four sources. One is the tides, waves, then the vortex, and the wind energy. No doubt, when you construct these machineries, it will disturb the ocean floor. But we can minimize those effects and see that there is no environmental effect because they are not polluting industries. For example, if you want to extract energy from the offshore winds, you had to install that turbine there. For that, a mast has to be constructed, which is on the ocean bed. So that effect will be there temporarily. After that, it is left its own. So it will become a fish aggregating device in the long run. And once it is constructed, it is not no more going to affect the ocean environment in that way. Similarly, the wave energy plants, they are floating devices. So they also should not be polluting devices for the ocean. And tidal energy, what will be done is just put a barrage on the, for example, take the Gulf of Khambat, construct a huge barrage and install those turbines so that as the water passes through this barrage, the turbines will work. So except during that construction period, it is not going to pollute those regions. Of course, nothing we can achieve without losing something, but it is the minimum interventions. Now coming to the minerals, for example, these polymetallic nodules, Seabed Authority has given strict norms on what should be the environmental disturbance when this mining is being done. And unless we show with the data which is being done right now, and it will continue during the mining tests also, that how much disturbance it is creating on the seabed and whether it is within the acceptable limits of what has been prescribed by the Seabed Authority of India. So that EIA study is extensively being carried out using different survey techniques, including moved equipments moved on the ocean bed to collect the data during these mining disturbances. So that will be taken care to large extent. Of course, I will not say that it is 100% not going to disturb, there will be some disturbance, but it should be within the limits of tolerance. So that those aspects are also being worried and tackled along with this. And now coming to the fresh water, that's what I mentioned, that if you use the RO technology, reverse osmosis, then the concentrated saline water is being thrown out as a brine into the sea. That is more detrimental to the environment than this technology here. After vaporization, only 15 to 20% of the water gets extracted or evaporated. So that water which is coming out of this low temperature desalination plants, it is as good as the seawater itself. So it is not going to change that environmental condition itself. So it is more environmental friendly than the reverse osmosis technologies.
Dr. Shenoi, I have two small questions.
Yeah,
One
please.
is about the warming of the ocean waters. Can we reverse it by any means?
We will not be able to reverse easily. See, now many of the studies says that even if you look at the last recent IPCC report, that is AR5 assessment report, AR6, which came out just April this year, it says that unless we reverse the emissions by 2025, whatever emissions should peak by 2025 at the present rate. And even if we reverse that, many of these things cannot be reversed in the near future. For example, water heat which has been put in the ocean, you cannot take out. So only thing we can do is try to stop further warming. For that, every country has to adopt to those technologies, carbon neutral technologies, and also as promised at the COP26 at Paris agreement, how much reductions they will bring. In that sense, we are on right track, because we have promised by 2030 nearly 40% of our electricity generation will be from renewable, non-renewable sources like solar, wind, hydro, etc. And some of the reports says that India has already achieved that target, and we are now keep on increasing electricity production so that we will reduce the electricity production from coal. But we cannot give away immediately because of our economic requirements and our developmental requirements. So if every country targets and meets those requirements, maybe we will be able to at least stop further warming, and it might take decades or several decades to further cool down the oceans.
Okay, the second question is about protection of marine environment. But Professor Venkatramani has already mentioned about it. I read recently in papers there was a huge hesitation when they planned to explore gas from offshore area in Western Australia. The Great Barrier Reef people, they have raised a huge objection, saying that it will affect the barrier reef. So what sort of measures we are taking, particularly coral reefs, wherever they are there, India and particularly in Andamans and other areas? What preventive measures are you doing?
Yeah, for that only this idea of marine protected areas or marine sensitive areas. Every government is supposed to at least keep aside 20 or 30% of the marine area as protected area. which is actually, as per the UN Convention, it is mandatory and has to be identified and kept aside, and developments or activities should be allowed within those regions. When this oil and gas extraction or those kind of things are being attempted, then we should also ensure that the better technologies are used so that the effect on the environment is minimized. I don't know any other things can be done, but I think that we had to make the legal framework such a way that these cannot be violated, and the government should ensure that these are followed. Otherwise, we cannot say that we will not extract the gas and oil because we are heavily dependent on that, and now 80% of our imports are going in oil and gas itself, and that is our major issue with our economy. So we have to see that how best we can tackle and move forward.
Who will do the protection of 20% of land, ocean is for land, whether it is states or federal government?
No, marine areas, I think it is because it is within the territory, mostly within the territorial areas, central government as well as state government together, it is a concurrent subject. So Ministry of Environment and Forest and Climate Change, MOE, FNASc, they are the agency which is engaging in this, identifying these areas and getting the state governments and central government notified those as several areas along the Indian coast has been done now, especially in the Gulf of Mannar region. I think almost entire Gulf is a marine protected area, most of the region, as well as on the west coast as well as the east coast.
If there is any other question, please. Otherwise, we can.
Yes, Mr. Parsar Balla here.
Yeah. Please.
Dr. Shenoi, it's a weird question, but it is in continuation of what Dr. Ramani had said. You see, I want to ask about that polymetallic nodules, that extraction of that. My question is that whether the cost at which we shall be extracting those is really worth it, or is only a pretext for technology development?
Right now, I must agree that the cost may not be viable. But if you look at the some of these estimated projections for the future, some of those metals which are likely to be completely depleted from the land areas. See, for example, now lithium, that is one of the highest sought after metal now, because all these electric cars and all the batteries, lithium as well as another element, and I don't remember its name. Those elements are, or those minerals are most sought after. So that's why now some of these countries have become very rich, like this Argentina in South America and etc. They have large deposits of lithium. So they are going to become the richest countries. Similarly, some of these metals like nickel, cadmium, etc. I have read in the reports that by 2050 or so, it will completely deplete from the land. No more it will be available. So that time we need the alternate sources, and these are elements which are required for the newer technologies which are being which are coming up. So that time this cost may not be huge, and the technologies also will improve for the mining as we are thinking now. Right now, if we calculate that, but a country which is whose life is thousands and thousands of years should not look at the immediate future. The planning and the development should take place on a longer perspective. So in that sense, I feel that we have to do that, and we should, of course, the immediate advantage is our technological progress and technological capabilities in doing such high technologies. And second aspect, right now we should not mine much, because I don't think we will be economically mining any of these metals in the next decade. Maybe after that only things will start becoming more viable.
Partharthi, can I do a follow-up question?
Yeah, I
No?
think
Okay.
you can.
Okay.
You can.
I gave
You
up.
can. You
Okay,
can
I
if
gave
you
up.
want. Only thing is a time factor. I'm worried about the time
Okay,
factor.
okay. Fair enough, fair enough. Thank you, Dr. Shenoi. Thank you.
Okay, I think it's my pleasant duty to propose the vote of thanks to Professor Dr. Shenoi for his very comprehensive and wide spectrum information on ocean studies. I
Can I
personally,
make a comment?
yeah. Yes. Who is that? Professor Ramani? Okay.
Yeah.
You want to make a comment?
Yeah, I just would like to make a comment.
Yeah, please.
I like the presentation. Let me make one comment about the presentation, which I like very much. It started out with Lord Shiva taking care of the poison that came out on churning the ocean. And I'm looking for such saviors in the future for all the problems that all good meaning people want to create by churning the ocean. And frankly, I think when we try to look at extracting mineral or life forms from the ocean to benefit only mankind on earth, when we try to kill other human beings, when we try other living things, whether they are plants in the oceans or other animals in the oceans, we try to eliminate a very essential part of the total of the total life system or total ecology or total ecological systems. And therefore, we do not have the capacity to think along those lines. And we are thinking, as Dr. Shenoi has correctly identified, probably the next 100 years, 200 years, or 1,000 years. The problems that we create are likely to live for 50,000 years, as we know from some of the nuclear waste and some of the water pollution problems, some of the mining problems we have created. And therefore, I will just caution that every attempt at solving one problem, we may create a lot of hidden problems. And the question of tapping these hydrothermal vents at the bottom of the ocean, we don't even know what they are and how they are, how that will affect the living organisms around these vents, which are probably the source of life for the entire life on this planet. I will just caution only from that point of view. And that does not take away from the great presentation. I really enjoyed it. Thank you very much.
Thank you, sir. You are absolutely right. That's why I made that point that all these can throw up environmental issues, and we should be prepared to worry about that as well as tackle that. That time, Lord Shiva saved everyone, but there is no more Lord Shiva. We ourselves has to save ourselves. So that's why just not developing the technology and going and disturbing the environment, we should also worry about the repercussions and take corrective steps, as well as minimizing those disturbances. Thank you very much.
To continue my vote of thanks, I thank Dr. Sailesh Naik and Mr. Rasik Ravindra for mentioning the name of Dr. Shenoi for this lecture today. In fact, but they have taken a lot of interest in this one, and then they suggested this should be there on a priority basis. Such an informative lecture, I thought it should be available to our politicians, our bureaucrats, and our academicians also in a big way, because they should know what is happening in the marine science as such. So they should know this. And as Dr. Ramani was mentioning, they should also know about the possible adverse effects of such studies also. That being so, I thank you again, Dr. Shenoi. Your lecture will be hosted in our website within next few days, and people can still ask questions through website, and then you can give online reply in the website itself. Those who want to ask questions, they can reply online. Thank you very much for our very illuminating talk. I thank all the participants of today for taking active interest and then listening to such an exhaustive and comprehensive lecture by Dr. Shenoi. Thank you very much. Thanks all. Thank you.
Thank you. Thanks to all of you for giving me an opportunity to deliver this talk. Thanks to all of you. Many of them, some of you I know, Dr. Geeta Vardhan is there, who was director of ADRIN in Hyderabad. I can recognize her, and some of the others as well. Otherwise, many of you I don't think I've met earlier, but it's a good opportunity, and I thank all of you for giving this opportunity. Thank you very much.
Thank you. Thank you very much.
Thank you. Thank you. It was a wonderful talk. It was a wonderful talk. Thank you so much.
Thank you, Geeta. Thank you, Kesha Swami. And it is not a group of geologists alone. A lot of non-geologists also are there in this group. Yes. And today's lecture is really highly appreciated by all the people. As I told, it should be made available to many others also.
Yes. Thank you very much. Bye-bye.
Thank you.
Bye.
Thank you. Bye-bye. Bye.
Where is Desikan sir? Today is a bad day. Our, our K. Krishan Nair.
Yes, D.B. Rao and over.
Desikan sir.
Are you? Yes, I was, yes.
Our Krishan Nair, you know Krishan Nair, no?
Yes, very well. He was working with me, no, that in Kerala, quaternary geology.
Yeah, he passed away this morning.
Yes, the GSA, our retired association, it has come. So, and then DP Rao also, it's a bad day, very bad day. I was about to talk to you, and now you have come on that Kasargod. Convey of my condolences to them, their family, because I do not know much where are they.
Okay, sir.
The meeting is over. All have gone.
All have gone.
Still we